I'm Professor Colette Fagan. I'm Vice President for Research at the University of Manchester. Welcome to this special Talk 200 event and the splendid venue at RIBA. I have two important housekeeping events before we start. The first is, if there is a fire alarm, please make your way to this exit and RIBA security staff will help you leave the building. The second, which is more certain to happen, is there is a reception at the end, and I would love it if you would find time to stay with us for discussions and meeting people after the event. This is the third of four major live events of Talk 200, the university's lecture and podcast series running throughout 2024, our bicentenary year. I'm delighted to be joined by those of you here in London and the many more joining us online for this lecture and panel discussion. The previous lectures and broadcasts, and you can pick up one of these outside to get the link, have covered debates including health equity, social justice, innovation, climate change and energy, and these can be all accessed through our university bicentenary webpage and the usual podcast channels. The university's 200th anniversary is an opportunity to reflect on our past, celebrate our present, and look to the future. And the Talk 200 series invites listeners to be part of this journey with us. The series features some of the nation's foremost thinkers and commentators from health and physical science, social science, history, the arts, and many more voices from across our community. I am very proud of our university and to be part of our community of staff, students, alumni, and friends. So let me just blow the trumpet a little bit. Our university is globally recognised for the quality of our research and the impact that it brings for the benefit of society and our planet. To give you just a flavour, we are among the top 50 in the world for the quality and reach of our research. We are among the top 25 most international universities in the world in terms of our staff and students. We are second in the world for the impact and contribution that we make to the delivery of the United Nations Sustainable Development Goals. And of particular relevance for this event, we are third globally in the Sustainability Index, which measures universities' ability to tackle the world's greatest environmental and social challenges. And this is all down to our staff and students. We're very pleased to be joined this evening by one of them, Mike Shaver, Professor of Polymer Science and Director of Sustainable Futures at the University of Manchester. Mike's lecture, The Unmaking of Everything, asks, how can we address the sustainability challenges of our material world? Professor Shaver will explore the complex nature of our material world and challenge our understanding of what sustainability means through a focus on plastics. Mike will examine our presumptions around plastic packaging waste, the complexity of these materials in essential objects, from our credit cards to conveyor belts to cars, and the interrelationship between these materials and our carbon footprint. He will explore how to recover value by unmaking these systems at end of life, and why unpicking this complexity is essential to recover value by recycling, reusing and deconstructing objects, components, materials or molecules, all essential for a more sustainable future. Following Mike's lecture, I will introduce an expert panel discussion, colleagues at Manchester, who will delve into how our university's interdisciplinary research in our material world can usher in a more sustainable future, from design and development to working with industry. The panel includes Dr. Helen Holmes, Deputy Director of Sustainable Futures, Dr. Rosa Juela Franca, a Senior Lecturer in the Department of Chemical Engineering, and Dr. Kieran Laheath, a Research Fellow at the Sustainable Materials Innovation Hub. Our online audience can join in with the Q&A by heading to www.slido.com and entering the hashtag Unmaking. So Mike, please make your way to the stage. Thank you.
Hi, everybody. Thanks so much for coming. And apologies for the slightly combative first slide. It's not the end, but it is an end. And when we think about the challenges that our world faces, and this is a lecture really about sustainability in its grandest sense, we have to first understand that there is a deep interconnection between these different challenges. Because climate change is not just about carbon or just about fuel, it's also about all of those other challenges that we face. So the challenges of pollution, the challenges of the circular economy, the challenges of social justice, the challenges of war, all of these things are interconnected with each other. And so this may seem like a pretty bad picture, but really the question that we have at the University of Manchester is, what way do we want this earth to turn? Do we want to turn towards our left side here and try and get a world which is genuinely, authentically sustainable? Or do we want to just give up? And actually, really what we need to do is to work together, to collaborate, and to build these relationships. And today I'll talk a little bit about our work and our vision, but also how that connects to so many different things that are happening around the world. So the unmaking of everything, right? That sounds, again, equally combative, like the end. But really what we have to do is to think more critically about how complex these materials are and how we can go and create value out of these systems. So the first thing is that this is all, unfortunately, your fault. Because when you make decisions, those decisions have consequences. So, you might need a beverage, right? Early in the day, that might be coffee. Late in the evening, it might be something else. But you have a choice to make in the receptacle you're going to drink out of. So you could choose this styrofoam cup here, or you could choose a ceramic mug. So just checking with the in-person audience, how many people would choose the styrofoam cup? One, okay, that's good. How many people would choose the ceramic mug? Lots of people. And by the way, the people that didn't raise their hand at either of those times, those are the robots, right? They don't drink at all. Bit of a concern. When did I raise my hand, though? I raised my hand for the styrofoam cup. Well, that seems illogical, right? But when we actually think about the energy embedded in these materials, we realize that we can make, transport, use, and dispose of over 500 of these styrofoam cups for the energetic cost of a single ceramic mug. Right? And when we think about that, that's because we have to dig up some clay from the ground. We have to fire a kiln up to a high temperature. We have to make that mug. We've got to transport it to, we're in London, so I'll say Waitrose, your Waitrose crowd. And then you've got to pick it up from Waitrose. You've got to then bring it back home, right? And all of those steps have an energetic cost. Now, you may be saying, well, but there's a difference here. I would throw away my styrofoam cup, and I would reuse my ceramic mug. And the question really is, well, are you going to wash it afterwards? Because if we need to make some detergent, we need to heat some water up, and we need to clean the detergent out of that water afterwards. That's the energetic cost of 2 styrofoam cups. And so what is the sustainable solution? Well, actually, if you were to go into any professor's office at the University of Manchester, you would see an unwashed gross mug that has had about 500 coffees in it, right? And that is because we really care about sustainability. But the reality is that these materials are so important to minimizing our footprint. When we think about packaging waste would quadruple if we don't have plastics. Food spoilage would double if we don't have plastics. Vehicles would be heavier, and our petrol consumption would double if we don't have plastics lightweighting these vehicles. And of course, the insulation that we used to previously keep our houses warm and now increasingly keep our houses cool would increase energy costs by 1.5 times. So this has been estimated to be 583 million gigajoules of energy per year. It's a relatively meaningless number, but if we convert that into the barrel of oil, which we do have a concept of, it's 100 million barrels of oil each year, which are saved by plastics. So why do we have this dependency on plastics? Why is this addiction so clear? Well, the first thing we have to do is to recognize that in any system, these materials are playing essential roles. And so if we think about where plastics are most demonized, right, the grocery store, and we go in, we're like, oh my gosh, waste conundrum. But that material has absolutely transformed our system for food provision. It increases food shelf life, therefore decreasing food waste. It improves food safety. So anytime we think about an alternative material, we must ensure that whatever provision we're doing, whatever we're packaging this in, has to keep that same function. So plastics are these diverse materials that have these important functions. But of course, many of the things that we have done with plastic are not good. Okay? So we might want to keep all of those things recycling, right? So you're going to go home and you're going to try and have a package which is recyclable. But at some point in time, a marketing person, and apologies if there is a marketing person in the audience, but that tray up at the bottom, at the top left, right? That meat is demonstrably sexier. And a marketing person figured out that when you take meat and you put it on a black background, well, you can actually sell it for more money. But that has a consequence because that black package is less recyclable than the white package, right? And we have a consequence both in terms of sorting in the system and in terms of keeping that material in its highest value condition. And so that's something we need to stop doing. But the challenge with that is that these materials, which might look like a plastic package, are exceptionally complex. And we think of them as simple, but actually they're exceptionally well-tuned. Because this is not just one thing. This is a plastic tray, a plastic reinforced paper tray, perhaps if you're looking at a modern material, a plastic laminated film, which looks like just a plastic sheet, but actually it's 5-micron thin layers of different materials with different functions. We have adhesives and heat seals, which are keeping that all together. And then maybe that paper label, which actually, to keep it waterproof, has a bit of plastic on it as well. And of course, underneath that meat is that adsorbent plastic mesh, right? And so what do we want? Well, we want these things to be kept in their highest value condition. We want these materials to be recycled. And of course, we can get someone in their home to rinse out that tray and put it into the recycling bin. No one is rinsing meat juice out of an adsorbent mesh. And so when we, as scientists, as academics, but also in industry, think about how these materials need to be designed, we have to design them around social practice, not around wishful thinking. And that is the key to unlocking change within that system. And so we might go and step back and say, well, okay, sure, that's all fine and good. Well, why don't we just start using different materials? And so maybe instead of that styrofoam cup, we wanted to use a paper cup instead. And actually, that paper cup has a higher carbon footprint than that styrofoam cup. But when we think about carbon footprint, we actually have to think about the whole use case scenario. So let's say I wanted to run a lemonade stand, and if you're at one of our events in Manchester, then you can actually maybe come to a lemonade stand that we run. You can see that we've got 1.84 kilograms of CO2 per kilogram of lemonade compared to about 6.2 kilograms of CO2 per kilogram of paper cups, which is about 3 times higher than the styrofoam cups. Okay? So that all seems like we really have to get the packaging right. But none of us drink lemonade. I know what I'm addicted to, and that's this. And if I think about coffee instead, actually I have 17.5 kilograms of CO2 in a single espresso shot, and I have 85.4 kilograms of CO2 in a latte. If carbon is everything, then we really have to understand how that integrates with the system that it exists in, integrate with those materials, instead of treating those things in isolation. And when we think beyond the grocery store, we suddenly realize that we have a huge challenge in our hands. So this is a group called Extinction Rebellion. I talked to them about plastic, and not these guys, they were busy. But one of the things of this group is that, in the past, they were sort of a zero plastic group, right? An advocacy group that wanted us to have zero plastic in the world. But of course, what they didn't realize is that these plastics were in their textiles, in their PPE, in their footwear, in their electronics, and even in the adhesive that is attaching this gentleman's hand to the London Stock Exchange. And the complexity of our plastic world and these polymers that we depend upon go much further than our addiction to plastic packaging. So our integration of these and the things that we value, well, that doesn't mean that these are materials sent from heaven and we need to keep this addiction. I'm not a plastic apologist. We actually have huge problems with this plastic system, but we have to equally recognize the importance of it. And so when we think about where these are really challenging, well, we have large objects which are littered. We have the breakdown of these materials forming micro and nanoplastics in our environment. We have plastic producers often deflecting criticism and not taking ownership of their part of the problem. All of these things coming together in a situation where we really have inadequate waste management facilities for these materials. And that's because we often have this priority of economy over environment. And so what does this actually mean for the broader system? Well, the reality is that this view that we need a more sustainable material, or we need something which is going to be a panacea or a silver bullet, well, that simply is not true. There is no such thing as a sustainable material. When we think about the future, what we have to first recognize is that these plastics hold massive societal benefit. And if we don't recognize that societal benefit, we're going to have severe unintended consequences. We also have to recognize that alternatives often have a higher carbon footprint, and we can't try and address a waste problem by introducing a problem in another bit of our sustainable system. We have to recognize that plastics are diverse, and this problem goes well beyond grocery stores, and that we need solutions which are integrated together, that are tuned towards those different fates of materials. So we need to reuse things, we need to recycle things, we need to deconstruct things, and if we can't do anything else, then we might be able to pyrolyze those things, but the thing we must not do is to release that material into the environment. And so when we think about our plastic-free world, it's actually that there are grave consequences about trying to imagine a future without this material. But if we don't deal with the problems that we have with its environmental consequences, we have equally grave consequences in terms of this extraction and pollution. So what do we do? Well, the reality is what we need is some sort of a sustainable system. So a sustainable material only exists in a sustainable system which can recover its value, which can control its release, and where we can recover that value from all plastic that goes through the system. And of course, our work, my research, is focused on plastics, but this same concept could be and should be applied to all materials which flow through our lives. And that is the concept of the unmaking of everything. If you were going to remember one thing from this chat, it's this. It does not matter if something is reusable or recyclable or compostable, if it is not reused, recycled, or composted. So the first thing we have to do is think about that system using past tense terminology and stop wishfully thinking about what might happen to a material and assuring that that fate is realized. So what are we going to do about this? It's a really hard problem. But luckily, 6 years ago, I joined the University of Manchester and met lots of brilliant colleagues, and together we're trying to address some of these challenges. And so I'm going to pick up just a few of the things that we're doing to try and pick up solutions to subsets of these challenges, just to give you a bit of a story about how we're working on this. So the first project, if I just go back, so this is this central thing, which is a project which we started 4 years ago called One Bin to Rule Them All. And so this started as a Lord of the Rings joke, as now is going to be something which ends up on my gravestone. But really what this is an integration of social science and economics and material science in looking at what happens in household waste management. During the pandemic, we got the fun task of actually getting outside our homes and going to sort through other people's waste. So when I say our team is garbage, this is actually a positive view, but really this is a remarkable community of people who are working together to try and solve these challenges. And what's great about the people we get to work with, the students at the University of Manchester, is they literally fight with each other for the privilege to go to a dump to sort through other people's waste, right? It's quite a remarkable feat. But what was really important about this is the ability to integrate an understanding of material flows, so quantifying all of the different materials which were in the homes of the bins, in the homes of the people who were part of this trial, but also the fascinating decisions which were being made about these materials, right? You know, this picture in the bottom right here where someone has chopped off the top of a Tetra Pak carton because obviously that bit is plastic, but the rest is not. And what we have is a deep and detailed map on both social practice and material flow. So what does that actually allow us to do? Well, it actually allows us to look at the supply chain of these materials in a very different way. And so in the past, when we think about plastic waste management, we demonize three groups, right? We say, okay, I've put this in my bin, it goes to a waste management company, and that waste management company probably does something dumb with it, and they send it to landfill or they send it to a recycler, and that's the bit of the system. But actually, the things that are happening are a result of decisions which are made across the supply chain. And so by looking across the supply chain, we suddenly see lots of different opportunities to make design decisions which are improving sustainability. And one of the simplest, if I just walk through this, is in the bottom right-hand corner here. So what if you don't mandate sort of all of these systems being the same, but you mandate material segregation? And so one of the experiments, I guess, we did was on looking at segregating food-grade bottles to being either made of PET or HDPE, so Pepsi or milk. Non-food bottles are only PP or other, but we don't put PET or HDPE in those systems. Food-grade pots, tubs, and trays are only PET or PP, and the non-food pots, tubs, and trays are only HDPE. The decisions that a waste management company can now make increases that value dramatically. So the waste management company, instead of losing money by recycling, can make money by recycling. You tie an environmental outcome to an economic outcome, and then you incite change across the sector. The second thing that I wanted to look at was, instead of thinking about those packages, to think about another material flow. So some years ago now, we were approached by MasterCard, and their CEO had got up on stage and announced the world's first biodegradable credit card. When it biodegraded, it released the barium from the magnetic strip and the 18 metals in the chipset into the environment, causing grave toxicological damage. It was an atrocious idea. They figured this out after the CEO had got up on stage, and then approached us to say, well, what would a sustainable card actually look like? And actually, the key is they were degrading something and they were releasing metals into the environment. Because if we switch the resin from something which is called PVC, so this is the same material that would be in your windows at home, and switch it to a material which is called PETG, well, that actually unlocks a new fate. We can now do a deconstruction of that card. We call that process depolymerization. And that depolymerization actually allows us to create a circular card economy. And so this is just an example of one of our scale-up processes. So we did about 300 credit cards in a single batch here. And you get all of these different materials. And what's really interesting is, like, I can go and create a bunch of monomers. And so these are materials which I can use to make a brand new credit card that has the exact same properties as the first credit card. But this is not driven by the economics of doing that polymer recycling. It's actually all the bits on the right. So if we don't actually do anything in that reactor, we can recover a full chip, right? We can actually reuse that chip. Or if we want to just do that really quickly, we can recover all of those different materials and reuse those materials. And by thinking about that card as a system, we suddenly can unlock economic value which goes well beyond the plastic recycling. And so by considering not only just the plastic recycling system and extending that to a multi-material, we unlock economic value and we drive that forward. So what's next? Well, next, really, we have to go to an even more complex system. And by a more complex system, we're really looking at a sense of scale. And so in terms of bottles, there's 580 billion plastic bottles which are put on the market each year. That's about 8.2 million tons. And each one of those is going through tiny loops, right? So if you put if you want some good news, right? If you put your bottle in the recycling bin in the UK, it will be recycled. Have confidence in that, okay? If we look at the credit cards, well, we actually have 6 billion credit cards, and not just credit cards, but also hotel cards or any of those laminated cards put on the market each year. That's 30,000 tons. So actually, even though that's a more complex material flow, it's actually not that much material compared to the bottles. And then we look at cars. Cars have 92 million vehicles put on the market each year. That's 173 million tons of material, and that's 15% polymers by weight. So we actually have more plastic material in the cars than we do the bottles. And so I was fortunate enough to get awarded a Royal Academy of Engineering chair to work with an ambitious electric vehicle company called Polestar. And if we think about, I pitched to them, oh, okay, yeah, we can do this for a credit card. Oh, cars are really hard, right? So if we think about this car as a multi-material, we suddenly realize that we have a huge range of different materials. We need to be able to separate those out. Each of them is going to have a different fate. And I have commingled with that glass and metal and so many different components that it becomes exceptionally difficult to recover value. Not only that this is a company because, if we want to go and recycle a milk bottle and put it into a milk bottle, well, that's a technical challenge. But to recycle a milk bottle and to put it into a car, well, I have a higher spec. I need to ensure that that is safe. I need to ensure that that still maintains the integrity of that car, and it's still going to be good to use for the entire lifetime of that vehicle. And so this is an exceptional challenge that we're working on now to try and make this as low a carbon footprint and as circular a vehicle as possible. Now, I've presented this as we are developing solutions. But what's really important to remember is that we are constrained by the laws of physics. And the laws of physics say that we always will have loss. And so the reduction of consumption is still going to be very important for a sustainable future. But we have to recognize that the limitation in infinite recycling, infinite reuse, infinite composting, and those things which simply will not happen, that breaks the laws of physics. And so we have to have a solution where we think about those transitions in as sustainable a way possible. So I talked about that sustainable system. But in fact, what we need to unmake everything is interconnected systems which work together with each other. And so we imagine this circular economy as an ideal. We want to be able to take that bottle and turn it into another bottle. But actually what we need to be thinking about is what we're calling a spiral economy. And so how does that bottle turn into our car? And how does that car turn into a chair? And how does that chair turn into, let's say, ID Manchester? So if we want to go to that point, we basically can have different intersectoral transitions which allow us to keep those materials in their highest value condition. And when we get to the built environment, when we go and sequester that carbon in something like ID Manchester, which is going to be a harbinger for innovation for the next 200 years, we can then take those materials and depolymerize those, take those back to a molecular form so that we can go and put those back into new systems. That spiral economy is about transitioning in the most sustainable way possible those material flows across those systems. Now, that means we have new words, right? And so I talked about the importance of past tense terminology. And so what do we need? Well, we need to ensure that all materials which come through our lives are valued. We need to ensure that all materials that come through our lives can be unmade, and that's so important from a design perspective. And the key out of both of those is we reduce, if not remove, our addiction to extracting virgin resources from our planet. And that is the key. And that's the key to unmaking of everything, is unlocking that economic value and preventing extraction. So, the next 200 years, where are we going? Well, so many of you in the audience will have come and traveled here today. You probably were like, this is going to be a cool lecture, so I want to wear my best jeans, right? I did that. And then you're looking for your best jeans and you realize that they're dirty, right? And so you've got to put them in the washing machine and then maybe the dryer, or maybe you've hung them outside. And then you realize that you don't even know where this place is. So you grab your phone and you're saying, well, I need to look on Google Maps where I'm going. And so you contact the server farm where the information is stored, and you connect and try and figure out what's going to go on at that server farm so you know where you're going. And of course, because it's a sustainability event, you're taking public transportation. Yeah, maybe? No. And so you're taking that public transportation all to come to this place here that we're sitting in, right? If we think about the complexity of the car, and then we look at the complexity of the multi-materials which are on the screen here, we realize how grand a challenge that we have. But that is the vision for the next 200 years. We remove our addiction to extraction. We recover value from all of these material flows. And we retain value in some of these objects, some of them as components, some of them as materials, and some of them as molecules, by making the things that create our world. Thank you.
Thank you, Mike, for really explaining the science, for having that vision of a spiral economy and linking that through to an understanding of systems, the work that's needed between scientists, economists, social scientists, and the practical challenges of tracing it through some of our everyday products and our role as citizens here. And I use a clean ceramic cup, so we've all got our little bits of gilt in the rim. Let me invite the panel, but first let's have a round for Mike. Sorry, thank you. Thank you. So as well as Mike, we have Dr. Helen Holmes, we have Dr. Kieran Laheath, and we have Dr. Rosa Cuela-Franca. Sorry, Rosa. So what we're going to do is I'm going to ask them each a question to warm us up, and we will then be coming to the panel, to the floor, sorry, and also I will be signalled when there's online questions so that we can really get under the skin of the debate here. So, Helen, where Mike left us, it really leads into the question I want to ask you, which are what are the social and behavioural changes and challenges that we must solve so that we can get the circular spiral economy really working over the coming period?
Thank you, and thanks for a great talk, Mike, as well. So I'm a social scientist, so very much focused on social behaviours and practices. And I really think that the challenges of circular economy and technological advancement need to pay attention to what people are doing with things. And Mike talked a bit about this in his presentation as well. Because if we don't, what we end up with are unintended consequences. So my work focuses very much on the everyday, on the minutiae, on the weird and wonderful things that we all do with the objects that surround us, particularly those at home. So to give you a bit of an example of where a technocentric solution for circular economy has gone wrong, you may be aware that a lot of plastic bottles in particular, or plastic waste in the past, has been recycled into sportswear. What wasn't really taken into account when that was done is that people wash sportswear quite regularly, and every time they wash it, thousands of micro and nanoparticles are released into the ecosystems. So that's one example. Another that I was thinking of when Mike was talking about credit cards, and I thought you might mention this, but you didn't, because I know it's something we've talked about before, is obviously we're keen to recycle those, but what do most of you do at the end of life with a credit card? Do you cut it up? So these practices are really important. And I've got one further one, so I'm sort of going from the negative to the positive here, hopefully. The projects that I've been involved in with Mike, which was mentioned in the talk, is One Bin to Rule Them All. And I was the person who was digging around in people's kitchens and asking them lots of questions about what they did with certain plastic items when it came to putting them in the bin. And it was very clear that people are incredibly confused. They're confused about what is plastic, and they're confused about what bin it should go into. So for me, I think it's really important that we have an understanding of how people make sense of materials, not just how they use them, but how they make sense of them. So to give you an example, Satsuma netting, plastic, where would you put that? General waste, plastic bin? Obviously it depends on your local authority rules, but we won't get into that because that complicates matters. We had other instances of, I won't say the name, but a very well-known crisps tube, where people were very unsure of what to do with that crisp tube, and we actually had people, a bit like the example there, where they'd be trying to cut the lid off the top of it because that felt like metal, then they'd be trying to get the paper bit off. So people were going to great lengths. I sort of want to end my answer on a bit more of a positive, that we can learn an awful lot from what people are doing with these things, but we can also show how people really are trying their best and they're caring about this stuff, and that really matters. And that brings me back just to when you were talking at the end there. You know, in a way, we used to have salvage yards, we used to have very thrifty activities, but we've moved to a place where that isn't the case anymore. You know, we're in a fast consumer society. So I think it's really about getting back to grips with the materials, engaging with what people are already trying to do. You know, we had people storing up pots, tubs and trays to take to their neighbouring area because they couldn't recycle them in their own neighbourhood. Lots of things going on. So recognising these different practices, and not just within the global north either. There are lots of circular economy practices which are grassroots, which are taking place in the global south too. So I think that would be my positive to end on.
Thank you, Helen. So, Kieran, we can follow on here in your career. What's the most surprising insight you've gained about all these materials and life cycles, and how's it shaped your approach to developing more sustainable alternatives?
Thank you very much. That's a very interesting question, because I work at the intersection between reusing and recycling, and when to do that action, and deconstruction. So the breaking of a material down and the remaking of an original material once again. And as Mike spoke about earlier, the complexity of the materials that exist in our modern world is extreme. And I spend a lot of time engaging with polymer producers, but also the customer-facing aspects of how polymers enter the world. And I think one of the most fascinating things for me has always been trying to understand the decisions that led to the increase in complexity. As a producer, you have all of these options, and you choose the various options that go into any given product based on a myriad of different options. You have a choice about how long wearing you want a garment to be, how structurally sound you want a dashboard of a car to be. There's so many different choices that get made, and these choices lead to the development of that complexity. And I think that trying to understand why those decisions were made and how we as sustainably minded scientists can interact with how industry has become successful and make it more sustainable without damaging that success, I think that really fascinates me.
Thank you. I'm going to move to Rosa now. Rosa, I know you're an expert on life cycle assessment and the methodology underlying that. So in terms of identifying unintended consequences in this Unmaking strategy, how is our pioneering work at Manchester helping to move us forward?
Thank you for the question. And just to give you a bit of a background, so life cycle assessment is an environmental sustainability tool that allows us to quantify all the different resources, materials, energy that goes into making a product and translate that into an environmental impact. So you're probably very familiar with carbon footprint or climate change. So this is just one example of type of information that we can get through conducting a life cycle assessment. And something that it's very important is that you have that conversation between the people that are making these materials, designing these materials, so we can understand all the different steps, all the different thought process that went into designing that when we're applying this methodology, because we have to go into the detail of what goes in, what goes out, what happens with it afterwards. And something that it's very fascinating happening in Manchester is that access to a multiple disciplinary resources in terms of the people working, because we can have conversations very early on about, I have an idea of designing this material, what do you think in terms of what are the consequences of changing this feedstock for this other one? So something that Mike mentioned in his talk is that sometimes the alternative is worse than what you're already doing. And life cycle assessment allows us to take that step back to reflect on how can this change make a positive or a negative impact. So having those conversations at Manchester with people in different disciplines involved in the making of a material is very valuable.
Thank you. So I'm going to come back to you, Mike.
Oh.
So you discussed and explained the complexity of the material world and how unmaking as an approach can help us recover that value. And I know you don't just want to study it, you want to change the world. You want to get us on the blue side of the image we were left with so vividly. So what's the role of academics and their research in dialogue and working with industry to get to the root of the practices we really can change to make a difference?
Yeah, if I bring together the answers from my brilliant colleagues, the reality is that industry, actually just like the public, they want to change. Sometimes they want to change because they want to influence consumer practices and they want to get more brand recognition. Sometimes they want to change because they actually do want to have a lower impact on the environment, or they want to meet stated climate targets. But they struggle to understand these complex systems because they lack the social understanding to understand how those materials are used. They lack the material understanding of what happens when you make things simpler and less complex, and they definitely don't understand life cycle assessment and the complexity of things beyond carbon, which are going to be potential deleterious impacts. And so academia is essential to those organizations because it helps them reframe what they think the challenge is, and it helps them actually get authentic answers, right? And so instead of trying to get the answer that they think they want, they're able to work with us and actually know what they should do, right? And that confidence is actually really powerful because it allows them to then change, right? And that confidence can only happen when you have interdisciplinary thinking at the core of how you're interacting with those companies.
Thank you. So I think you can see why I love working at Manchester, because we've got brilliant people here really getting to grips with important questions. And this is just a sample of our community of colleagues at Sustainable Futures working on these challenges and more. So I'm going to end with them with the question we ask in all our Talk 200 bicentenary lecture and podcast series, and then I'm going to come to you. So, final question. What do you hope our third century at Manchester will bring to the area, this area of sustainability? I'm going to start with Rosa.
I think having end of life present when you're designing a material, that becomes the norm. You're designing a material, but you're thinking, what's going to happen to that material at the end of life? And that becomes a crucial part of the design. And another point to make is that sustainability should go beyond a nice thing to add and the mandatory metric that you need to provide alongside the design specification.
Thank you. Kieran.
My answer is actually very, very similar to Rosa's. In reality, I think that in the next 100 years, I would like to see a world in which we're not making things without having that initial thought. New materials being invented by material scientists all over the world. It happens every single day, but these materials are being produced without that thought. So prior to how they end up in products on the market, it's in that initial invention phase. I want a world, or I hope to see a world in the next 100 years where the materials innovation space is directly plugged into sustainability, and that it's thinking about those things in the invention process, not at the end of invention process.
Thank you. And Helen, as a sociologist like you, what's your vision and how are we going to work with these material scientists?
So I think for me, over the next 100 years, I'd really like to see an accelerated focus on interdisciplinary research where it becomes the norm. But when I say that as well, I think it's important to say that this isn't just working with different disciplines, which I think is vital, and we have to do that to tackle these wicked problems, as they're called, we're currently facing, but also with, as Mike has mentioned, with experts beyond the university, so with policy, with industry, with the third sector, and importantly with publics as well. And that's got to be co-productive, it's got to be collaborative. It can't be us bringing people in, you know, at the end to say, what do you think of this now we've done it? It's got to be right from the start. So that's what I'd really like to see.
Thank you, me too. And Mike, the last word at this stage.
Well, I mean, they've already stolen all my answers. So, well, no, I'll pick up on one thing which I think is going to be really important to unlocking the change that we've been talking about this evening, and that is openness. And so oftentimes across these supply chains or across these materials, we don't know what we're dealing with because the material complexity is locked behind trade secrets and locked behind closed doors. And actually, having systems which are empowered by open data takes the power and shares it. And so it's not to say that, you know, your Heinz ketchup is not still your Heinz ketchup, but it actually is going to be really open in terms of being able to share the data that we need to share to unlock those sustainable fates. And that, I think, will be transformative to actually making better decisions across supply chains.
Thank you. So now we're going to open for discussion. We've got two colleagues with mics in the room. Thank you. I've got two colleagues tracking online who will signal to me when there's a question there. And if you have a question to a particular member of the panel, please signal. I'm going to try and avoid the 4 people provide an answer to every question so that we can move things along and give them a little bit of a break as well. So, great. Well, sorry, the gentleman behind you's hand went up first and then you're second. Thank you very much.
Oh, thank you very much. Question for you. How much do you think measurability is an important part of this? Because looking back in time, you find that usually we don't manage to measure the damage that the new product is causing until some decades, centuries afterwards. A lovely example, I worked 50 years ago on looking at the possible fact that mercury would run out in 10 years' time, which is the consensus at the time, MIT, Club of Rome. And we looked at these recycling things, but what you found with mercury was that it took a time before there were measuring tools that could detect the parts per million of mercury in the environment. And some of you may have recalled Minamata Bay when many people were dying or going mad because of mercury in the environment there. And you only have to think, sorry, just one more example, which is a funny one really, from Alice in Wonderland. You may all have wondered where the Mad Hatter came from. And he came from Luton, I can tell you that because I come from Bedford. And this was because to make the hats which used beaver, they used mercury, and therefore the people in Luton were suffering from mercurialism, and that's why they were mad. But we didn't have tools to measure that, and no one realized at the time. Sorry, the question is, do we need more measurement at the time we introduce more materials?
Thank you. Who wants to?
I think that's definitely, so I mean, I think Rosa and I would definitely argue for measurement. But measurement can mean two different things, right? So we can measure the impact of a process, or we can measure the quality of a material. So one of the challenges with recycling is it good enough to then go back into a product? That is an area of research which we're working on actively. I could give another 20-minute talk just on that. We can pick it up later, but it is essential that not only that we have good measurement techniques, but that those measurement techniques are open as well. And you might pick up on LCA as well.
Yeah, so we have tools, methodologies that will allow us to do certain quantification of impacts. But with the development of new materials, like nanomaterials, for example, we have a lot of catching up to do because our current methods don't capture those impacts. So there needs to be a bridge between what are going to be the consequences of these materials and how are we going to measure something that we don't know. How are they going to affect? So yes, and it's going back to your example. So there's some catching up to do, but it's being aware of that and working in parallel with the development of those materials and how are we going to provide useful measurements, not just numbers for the sake of it. But yes, definitely measurement is very important.
Thank you. And we have a gentleman here with a question. And, I can see the hands going up now. So, goodness, right. Let's start with you, and I'll come to you and try and keep a list of everybody.
At my age, I think global warming will probably last me out. So if I didn't have any spark of public spiritedness in me, I'd put everything into the waste. But I'm nerdy enough to actually pick up bottles and cans in the street and put them into recycling. But I've got 3 20-year-olds in my house who would put everything into waste because they feel that what they're doing doesn't make a difference. But what it seems, getting back to your thing about the Pringles, container. What happens if I put something in the wrong bin? I mean, we're all told that if you put a baked bean tin in the recycling and you haven't washed it out properly, everything goes to landfill. Is that correct? If it's, but I mean, it just seems to me that the information given is lacking. Even in London, many of the boroughs, they've got different rules and different things. And I read somewhere, there's some boroughs somewhere, they've got 11 different recycling bins. So can you help us out on this?
We certainly didn't plant this question, but I'm going to pass immediately to Helen on this one. Thank you.
I could give a day-long presentation on bins. The work that we've done, I am known as bin lady, I think is the current one at work. So yeah, and totally echo the confusion, and that's something that we have tried to unpick quite a lot. There are so many different rules, so many different bin colours. We've actually written a policy report on this, which you can, I can give you the QR code for if you want later to have a read of. In terms of what happens to your waste, and you can correct me if I'm wrong here, I think it would vary. So it would vary which local authority it was, then which waste facility it went to, whether the unwashed baked bean can made a difference or not. And I'm sure Mike will tell you why the unwashed baked bean can is a problem in a moment, for some and not for others. So there will be instances where, unfortunately, a load might be contaminated and it may then not be dealt with in the way. So all the way it should intended to. So when you put something in the bin, you hope it goes to recycling. When it then gets to that point, we also hope it goes to recycling, but it cannot always be guaranteed. But I just want to add one small thing about the 20-year-olds and the disillusionment, which is something that we've talked about quite a lot, that a lot of people are sort of thinking, is it worth it? Perhaps not helped by our previous government saying that recycling isn't worth it and that ending up all over the Daily Mail. I would always advocate that follow your local authority rules. They are probably very complicated. We're hoping things are going to become simpler moving forward. And if you can recycle, do recycle. And hopefully that message will get to younger generations as time goes on. But I'll let you sort out the baked bean question.
Technically, yes, it's recyclable, but if your local authority is too lazy to wash anything, then it won't be. But that's a decision. That's the difference between recyclable and recycled. So the local authority rules differentiate that, not the potential for it. Easily recyclable.
Thank you. So I've got a cluster of hands here. So I'm going to do a few here and then come to, no, just the gentleman 4 rows back. Thank you. Yeah. And then I'll take the gentleman behind as well. And then the rest of you are going to have to fight with your hands. I'm trying to make this.
I'm very glad that a social scientist is part of the group. But one thing I don't think we've mentioned is the role of politicians in rewarding manufacturers and retailers who are going in the right direction. An example might be what's colloquially known as a sugar tax. And look how controversial that was. But I've just wondered what thoughts, I'll let the chair decide who answers, but what role you think politics and politicians should play.
Do you want me to? Massively. So when we finished the project, as I said, we've got this policy report which we then fired out to as many different people as we could. We do think that's influenced the last government's policy, whether that gets put through. It's called simpler recycling. We're not sure whether that will happen or not. We've been in conversations with DEFRA and other agencies. But yeah, it's huge because actually they've got the power to be able to facilitate change to where it matters too. And for us, I think the argument would be that the whole of that supply chain needs looking at. So it's right down to what happens at the local authority level, what happens to the waste processors and the waste treatment and the recyclers, but also right at the front end as well, from raw materials and design, manufacturers, retailers, right the way across. So there's a massive part to play, and we can only hope that our voices are heard in that sense.
And just to follow up on that, this is not just in the UK, right? So both Helen and I were part of policy briefs that went to the UN plastics treaty negotiations as well. So you have to influence at the local council level, but you also have to influence nationally and internationally. And it's almost validating to have the buy-in and having those politicians sort of at least acknowledge or listen to a little bit of what we're trying to say, but it's exceptionally important.
Thank you. The gentleman immediately behind had his hand up a nanosecond after first off the whoops, so we'll take you, please.
Thank you very much. I've recently become a granddad. I have a 1-year-old grandson, and it's years since my wife and I have had to buy toys. But when you go out now, you're just faced with a myriad of plastic. Now, you've looked at packaging, you've looked at cars, but toys got to be a massive problem. And when you look at them, there's a mix of metal and all different types of plastic in there. So my wife and I, we try and look towards wooden toys if we can, but maybe that's not sustainable. Maybe that, from what you were saying, Mike, about transportation and the other costs, but we look for those because at least we think it might degenerate. So what work are you doing on toys? And am I right in thinking wood is better? Thank you.
Yeah, probably. Do you want to take?
Yes.
You can do that.
I'm personally currently not doing anything on toys, but it's definitely something that I think would intersect very heavily with a lot of the work we are currently doing. I would say that the material that's used to make Lego is one of a very commonly used material in the automotive sector also. And I think that in that sort of a sense, I think every sector that we investigate allows sort of the generation of knowledge that can be then transitioned into other sectors. So packaging influences learnings that can be utilized in looking at the automotive sector, and then that can then lead to further sectors. I think that within the sort of concept of toys, I think the decision-making processes are the ones that need to be investigated. It's like what kinds of toys and then what kinds of materials are necessary for those toys. Because if a child wants to play with a water gun, I don't know if that exists in made out of wood. So it's a sort of a challenge where it's like what exactly is the toy's purpose versus what materials would be the best choices for that. But unfortunately, I'm going to have to throw it back to Mike as to whether plastic toys or wooden toys.
Wooden toys have a higher footprint and a higher water impact than plastic toys. But I would actually step back from that and say, well, what toys are you buying? Because if you buy Lego, well, the whole experience around Lego is build and rebuild. And that actually is ensuring reuse of that toy, right? And so where are you buying it from? Are you buying it from a charity shop and you're actually reusing that toy as your grandchildren age? Or are you buying toys which encourage active play? And I think that actually the process of thinking about what play you want, that is tied to then them really getting those early experiences about what sustainability means. So buy more Lego.
Thank you. I've noted you at the back, but I'm going to come to a question from our online, and I will come to you next. Thank you.
Thank you. So a question, so I'll ask two if that's okay, because we've got quite a few questions that have come through. The first is a question for Dr. Rosa. So one major challenge in developing new techniques is scale. What are some of the challenges in scaling up proposed technologies for industrial use? And then the second question is from a member of our online audience called Warren. And he's asked, how are large countries like China managing their recycling processes?
So I'll take the first question.
Okay, and the second is
Oh.
Mike. Could take it. Thank you, Mike.
The main challenge with scaling something that is not conceived or known is data. So how are you going to generate the data that you need to make those projections of something that, what would it look like? But it's a very important exercise, especially at the early stages of designing a new technology, to have a feel of how would this look like if I translate my bench scale experiment to an actual industrial process. And even though the technologies that might be associated with that processes are not there yet, we can get a good idea of how many steps would it take to go from A to B, and have a feel of the intensiveness of the resources and the energy that is going to go with it, and at the same time keep an eye on the economics as well of that process. So it's a good exercise to think about what would this idea look like, but it's the reliability of the data that you use to make those assessments. So it's very important to keep that in mind and make sure that the data that is used to inform those assessments are as robust as possible, considering that it's something that we don't really know much about. So there is a big challenge there in that sense, but it's a good thing to consider.
I would also love to add on that life cycle assessment as a tool is becoming more widespread, and it's therefore being integrated into the technological development process so that people can identify hotspots, problems that are areas of a technology in its infancy, and develop workarounds, solving those problems early on so that you don't get to the end point and then have to figure out that it's a big problem. I think that's a really nice thing that's evolving at the moment.
Thank you. And Mike, China or other major economies?
Wow. So I think, so if we think other countries, right? So each country has its existing waste management infrastructure. Sometimes that waste management infrastructure is informal and they don't have sort of set up facilities like we do, and so we want ours to be better, right? So our 20-year-olds stop being jerks. But in other countries, it's so informal that we actually have to think about the consequences of any one of those changes. One of the things that is true about other countries, and this does include China, is that there is a greater focus on pyrolysis. So this is, sometimes in our lab we call this posh burning, but sort of breaking things down either for energy or not keeping them in their highest value condition. And I think that's very challenging because you're not necessarily retaining the value, and there's going to be an environmental consequence to that. One of the things that we've talked a lot about is data, and one of the things that's a big unknown is the quality of the data that's coming out of those other countries. And so when we look at this unmaking of everything on a global scale, well, really, we have to be able to do projects all over the world, to have a global responsibility about how the technologies that are imagined will ensure fate as those countries change, from China to India to wherever.
Thanks, Mike. So, person at the back, it's quite dim in here, I can't see, but I'm going to come to this side of the room who are feeling neglected, I can see. So I've got two questions there. Thank you. So.
Hello. This is about interdisciplinarity, so it's probably for Helen and Mike. But you talk a lot about trying to contact people in industry, which is great. But many of them may not be receptive, or you may never be able to contact them. Wouldn't it be worth, or I don't know, I'm asking whether there's any focus on teaching children about the circular economy and teaching them this interdisciplinary thinking way before they even go to secondary school, way before they decide what subject they want to do, way before they decide they want to be a product designer or a CEO of a company or whatever, so that we all in the future have this thinking and we all start from the same level, essentially. And is there anything happening, or do we need to talk to the Department for Education about that?
Before I hand to Mike, it's also the university curriculum where I know colleagues have been doing some fantastic things. So, Mike, I'll give this one to you.
Yeah, it's essential, and effectively the earlier the better when thinking about sustainability. Interdisciplinarity is hard for adults because we often use different words for different things, right? And so part of the journey to enable interdisciplinarity is to actually take the time to talk through the messiness of those problems. And I think one of the challenges is the constraints that we have on time, right? Where we need the teachers to be able to engage with that messiness to then be able to really get kids talking about that messiness in the right way. So it's essential. The Department of Education has not invested, I don't think, enough in the integration of sustainability education in the UK. We have some exceptional people at the University of Manchester who are working on this, and really it's about ensuring that access to information. And one of the things we want to do is to sort of develop a series of primers where it becomes accessible, where we have this sort of open access training where anybody can go and do that. The key is, again, that challenge of time, right? So having the time and capacity to go and create that is going to be essential to enabling that, not just in schools, but in all environments.
Thank you. So there's a gentleman at the back, and then the fifth row gentleman, please. So thank you.
Good evening. Do anyone on the panel think that in the next 200 years we'll stop using crude oil, stop recycling used oil? Will we have high-powered machinery that doesn't need lubricant or petroleum fuels?
I would answer that by saying I don't think we will ever, never extract a little bit of oil. Maybe we will, maybe we won't. I would say that we will, over time, get better at making the use of those materials more limited. That would be the only thing I can suggest.
Down to the gentleman in the fifth row. I mean, I'm looking over here for hands. I'm going to take one more hand from this side. Yes, I can see you. But
just to comment on that last one, I think you can actually synthesize a lot of the products as well. So from hydrogen and even from carbon dioxide and make products. My question is really looking at internationally. Mike, you talked about openness, and you said that we need to get openness. But you talk to, say, a company like Polestar, who are making cars, and they want to be open. But how are we going to succeed internationally when you look at, say, China, other countries in the Far East? We get so many of our products made in those countries. They're not manufactured here anymore. They're manufactured somewhere else, and we don't have any oversight into their production methodologies.
I think that's if we tether that question back to the question about measurement, right? So when we are importing materials, how do we have an assurance that the material is what it says it is? So this is becoming not just important for us, right, as consumers, but also for companies who are really struggling with the complexity of their supply chain. So international companies who are trying to make those sustainability decisions are desperate for good quality information. And that means we need to improve our analytical methodologies to be able to understand the differences between what is being marketed and what is actually showing up. And that actually then allows you to know how to use the materials correctly so that you get the desired quality of product and you stop having waste. In terms of your sort of follow-on comment, I absolutely agree that the first thing that is going to be a transition is moving away from our use of oil for fuels. And so synthesizing fuels will stop our addiction to burning stuff, which is actually really quite valuable in making some of those more challenging products. We have to also think about the footprint of a CO2 methodology and whether or not it's higher than what we would be doing normally. So very complex.
Thank you. So I've got a question over here. I've got one question on Slido, and I'm sorry, the two people whose hands up, the one behind you did come up before, and we will have time in reception for you to nab people. So please.
Yeah, this follows on from some of the previous questions and comments. I was wondering if you're doing or thinking about doing any work with environmental charities, because I've been concerned sometimes that some of the advice they're giving, and indeed some of the campaigns they run, are not scientifically based and are actually taking us in the wrong direction.
So I think there are, just like the academics up here, there are a hugely diverse range of environmental charities. Some of them have super sensible initiatives. So RAP in the UK does a lot of really, really good work influencing policy in this space. And then there are some environmental organizations that haven't been following the science. It just shows how important it is for universities to exist not just as a nexus point between academic knowledge and industry, but also policy and NGOs and all of those groups. So we've done a little bit in that space, but there's always an appetite for more.
Thank you. That's a really important question, as have been the others. Olympia for the question from Slido. And then it's a gentleman on the back. But no, I'm sorry, it's the one behind you. But the two guys who've been putting up their hands, please come and find the panel afterwards. So Olympia.
Thank you. So a question from Diego in our online audience, who's asked, as Professor Mike illustrated, what appears sustainable isn't always so, and it's not just about choosing the most sustainable option, but finding out what's truly viable. And in exploring sustainable choices, we see that some products are made more sustainably abroad, even considering transportation impacts. So the question is, how do you integrate research and academic insights into real-life economic decisions to choose a sustainable path without becoming overly dependent on another economy? And how do you address the associated political challenges?
Whoa.
It's a big one.
So I think some of that has been demonstrated actually in the lecture this evening.
Yeah, I think one of the really important things to realize is that I put the planet up for a reason. Like, yes, we are in the United Kingdom, right? And as a proud Commonwealth escapee from Canada, we have lots of global influence as the United Kingdom. But we exist in a world with really complex supply chains. And so we have to recognize that that world in itself is the largest system which we are trying to optimize. And that means we have to build international collaborations, right? The university has exceptional collaborations. We were just talking earlier about a new project with Melbourne that we're going to be kicking off. And actually, it's about using that international reputation and network to be able to go and understand the systems in those other countries, but also then incite change.
And make practical interventions into a huge, complex system, rather than stepping back and saying, we can't do anything, it's too complicated. So the last question thank you. That's others in the room. I'm really sorry. It's lovely to see so much interest in the questions. Please do bring them into the reception, because I'm going to get the wave in the moment about guillotining on time. So over to you, please.
There's carrot and stick. The carrot is the economic value. The stick could be regulation. How much are you doing to influence regulators?
Lots. So we have very strong connections into government and all kinds of bits of that. We have submitted way too many reports into different consultations. We interact a lot with the emergent, what's called extended producer responsibility steps, which are going to be coming into play. As Helen had mentioned earlier, a lot of the language that we wrote was then lifted into this simpler recycling policy. It's essential for us to work with those regulators to make sure that the right decisions are made. The challenge is that all of these things require nuance. And nuance and policy don't always go well together. And so the key is to make sure that the right nuances make it in to the policies which are emerging and that the regulators are going to be looking at.
We know also from other work at the university through our Policy at Manchester and other outreach activities, shaping policy can be a long haul if you've got to keep getting the message out there and you've got to keep coming back to it. So it's part of the solution as part of the system, regulation, incentives, practical solutions and driving forward. I now need to draw a guillotine under this. We've had a really, really helpful and stimulating discussion, and I know there are people feeling, oh, why wasn't my question answered? Hopefully we can get to some of those in the reception. Thank you to my colleagues who've been filtering from our Slido colleagues up in the air somewhere. I'm pleased you could join us. But let me just make a few closing remarks. Thanks, Mike, Helen, Kieran, and Rosa. Thank you to the audience for your patience with my news night trying to find you. Do take a look at our final lectures. Some of you may know we've got our new president, Professor Duncan Iverson, and he will be doing his first Talk 200 in November. Details on the leaflets out there. I will be at the event, so it'd be lovely to see some of you join us as well. And beyond that, please join us outside for drinks and canapes. I'd like to say they're going to be on styrofoam, but they're probably not. And that's okay, because nobody likes to drink wine out of the styrofoam, do they? So thank you again for joining us, for your ideas, your contributions, your continual support and engagement with our university. Thank you very much.